All right, let's practice how to make compounds from their names and how to kind of balance them because they're not always one-on-one. So, for example, we have a compound formed from potassium ion and oxide ion. So by the beginning, you know that potassium is going to be a cation and oxide is going to be an anion of oxygen. So you need to look up where potassium is, and it will have a positive charge of 1 because it's in the very first group. So it has 1 electron on the outer shell, and it will easily give it off. And then oxygen, if you remember, is in group that would be 16. So it has 6 because it has P4, so it has 2 s electrons and 4 p electrons, and so it is missing 2 electrons. So it will tear off 2 electrons off of other atoms and become a negatively charged ion, or anion. And so if you look over here, we have a positive charge of 1, but 2 negative charges. So in order to balance this equation, I would need to have 2 positive ions of potassium and just 1 negative ion of oxygen. So 2 positive potassium ions, cations, and 1 anion of oxygen, which has a negative charge of 2. So together they will give me potassium oxide. So we have K2O, because again, potassium ion will have a charge of 1, and an ion of oxygen will have a negative charge of 2. So I have to balance them out. Another example, well, we talked about how they have to add up to 0, so sodium ions and chloride ions, and then aluminum sulfide ions. Compounds, I'm sorry. So sodium ions plus chloride ions. Sodium will have a positive charge of 1. Chloride will have a negative charge of 1. Wow, how easy, right? You have sodium chloride as just NaCl, and there are no subscripts. Now, aluminum sulfide. Aluminum has a positive charge of 3. Sulfur has a negative charge of 2 because it's missing 2 electrons, so it will tear them off, and aluminum will easily give up 3 electrons. You can also look at it where it is. So it has 2 s electrons and 1 p electron, so it's easily giving up the 3 electrons that are on the outer shell. So because we have 3 and 2, there are 2 things that you can look at when you think of balancing it. So the common multiple for 3 and 2 is 6. So I can have a positive 6 and a negative 6 charge. So in order to get me a positive 6, I would need 2 ions of aluminum. In order to give me a negative 6, I would have to have 3 ions of sulfur or sulfide. And so therefore, I will have 2 aluminum and then 3 sulfur ions, sulfide ions. So I will end up with aluminum 2 of those, and 3 sulfide. And that becomes my aluminum sulfide compound. Okay. Here is where you can look up your numerals: 1, 2, 3, 4, 5, and 6. And so if we're talking about an iron cation that has a positive charge of 4, we're talking about iron 4. So again, when we talk about transitional metals, you have to identify it. You have to state the charge of that cation. So what if we need to write down the formula for manganese 4 sulfide? So again, we already looked at sulfur. Sulfur has a negative charge of 2, and then by saying manganese 4, we're stating that manganese will have a positive charge of 4. Sulfide has a negative charge of 2. Now here, if you do the crisscross, you would have manganese 2 sulfide 4, and then you would have to simplify. Or again, since this is a positive 4 and that's a negative 2, I kind of guess that if I have 2 of sulfide ions, I can balance out the positive charge of manganese, which has a 4. And so that is how I arrived at manganese 4 sulfide. What if I have to have a silicon oxide? So silicon has a charge of 4. Oxygen has a negative 2 charge, oxide. So therefore, again, 2 by 4. Since this has a 4, charge of 4, this has a charge of 2, I would need 2 of these guys. Or again, crisscross and then simplify. So we have silicon oxide looking like this. If we have polyatomic ions, we have 2 ions, and one of them is already not just one atom. For example, phosphate, and in the periodic table that we use in class, you can look up what phosphate looks like, and it also will give you the charge on it because it's an ion. So phosphate has a negative charge of 3, and then calcium has a positive charge of 2. So again, the multiple is 6, so I would need 3 of these and 2 of these. And so since this right here is not just an element, but is already something that is made of 2 atoms, I'm going to put parentheses around it and then put 2 behind the parentheses. So this is what it's going to look like. So calcium 3 and then phosphate 2. Again, we're balancing them because you have 2 and 3 and you crisscross them. So 2 goes to phosphate and 3 goes to calcium. So this is your calcium phosphate. Okay, to write the compound name, write the cation, and then, for example, we have iron and oxygen, right? And obviously it's going to be oxide. And then how do you figure out if iron is a transitional metal? So we need to state what kind of charge that transitional metal will have as a cation. So what I'm looking at is this right here. So obviously we crisscrossed. So we had iron and we had oxygen, and then oxygen had a negative 2, and then iron would have a positive 3. So because of this, I know that this right here is going to be iron 3 oxide. So that's how I'm naming it, by just looking at the formula. So if we have just no prefixes nor suffixes, this is easy. I'm just looking at the first. This is cesium, and then this is bromine, and then since it's an oxide, I mean not oxide, since it's a compound, instead of bromine, I'm going to say bromide. So I kind of, instead of an E, I'm going to end up with a DE, because this is bromine and then this is bromide. Anyway, that should be easy. Another example, if you have polyatomic compounds, you don't really change anything, so this will be calcium hydroxide. Okay, so let's go ahead and name these guys. We already had this example, right? So this has iron 3 dioxide because I'm looking at the charge on oxygen. So iron 3 oxide. Now I have manganese and I have potassium. I mean not potassium, phosphorus. So manganese and phosphorus. Again, crisscross. You can see that it's manganese 5 and phosphorus will become phosphide instead of phosphorus. We chipped off the ending of the word phosphorus and added IDE to it. We have cobalt, and then we have sulfur. And then you can see that cobalt here has a charge of 2, so that's why, but it's not 2, because if you look at, if you remember that sulfur has a charge of 2 minus, and that will mean that our cobalt has a 4 plus, and that's how they crisscrossed. So therefore, it's not 2 in this case, because you need to think of the charge on the sulfide ion. And so therefore, again, when you kind of unveil this formula, you end up with the name for this compound. So cobalt 4 sulfide. Here we have potassium sulfide. Then right here, this is not an ionic compound. So this brings us back to covalent compound. And remember, in covalent compounds, the first element you say the way it is, but you put a prefix in front of it. So triphosphorus, and then we have, again, we need to put the prefix for 4 is tetra, and this is chloride. Again, instead of chlorine, we say chloride, but we're not saying ion because this is not an ionic compound. So triphosphorus, tetrachloride. Then we have right here, this is a polyatomic compound, and you can look up again in your periodic table what this is, and you end up with, this is carbonate, and so sodium carbonate is the name of our compound. And then we have copper and bromide, and again, the charge on bromide is 1 negative, and then charge on copper as 3 positive. That's why we end up with 3 bromide anions in this compound. So we have copper and 3 bromides. All right, now we need to write down the formula. So nickel 3 selenide. So nickel 3, which means that it will have a charge of positive 3, and then selenide, the charge on the ion of this element is, as you can guess. So if I were to write out the ions themselves, this would be 3 plus, and this element, this ion, would be 2 minus. And so they balance each other out, and we end up with nickel 3 selenide. Now, heptanitrogen difluoride. So we have hepta, and then we have nitrogen, and then we have D, and instead of fluorine, again, we have fluoride. Hepta stands for 7, and then we have, there we go, nitrogen and fluoride. Beryllium hydroxide. Hydroxide is OH, and it has a charge of -1. Beryllium has a charge of positive 2, so therefore we need 2 hydroxide ions to balance this out. And then aluminum sulfide. Aluminum has a positive charge of 3. Sulfur has a negative charge of 2, and then again they balance each other out, and we end up with aluminum 2 sulfide 3.